Today we're going to be looking at the 3-2 Day 1 notes. Before I begin discussing the problems, I ask that you complete the warm-up by pausing your screen, doing the problems, and then once you're ready to go, please begin playing the movie. The movie, like you want to be watching what you're watching right now. You know what I mean. So go ahead and please do the warm-up now. Here are the answers to the warm-up. Please email me if you have any questions. Today, we're going to be looking at log functions. And log functions can be very scary when you first learn them. Thankfully, this is your second time learning them, so hopefully it'll come back. And if you do have questions, please let me know. First things first is we have what is being represented here is a log function. You will see that for every log function, there is this base b, and we have on the right-hand side of the equals what we call the exponent. You should remember from last year that we use the expression the circle of life to convert from log form to exponential form. What do I mean by this? You're going to start at the base, go over the equal sign, and that's going to take you back to what we call the argument of the log. So this piece right here, I'll highlight, is called the argument of the log. So if you look to the right, you'll notice that to go from log form to exponential form, you start at the base, you go over the equal sign, and what is on the right of the equal sign becomes your exponent, and then that's going to equal the argument. Now, so you know, exponential and log functions are inverses of each other, and you'll see the connection very well when we're doing graphing. But for right now, let's talk about log form and exponential form a little bit more. If you're ever asked to write an exponential form, you're going to use the circle of life. You're going to start at the base, go over the equals, and that's going to equal the argument value. So in other words, 3 to the 4th power equals 81, and that's it. If you see a log with no base, you should remember from last year that technically it has a base of 10. So we go 10 over the equals is going to equal this quantity here. So 10 to the negative 3rd equals 0.001. And you should see that that is a true statement. The final problem in this set is 16. Go over the equals, that becomes your exponent, and that will equal 1/4. So 16 to the negative 1/2 power equals 1/4, and that is also a true statement, because remember, negative exponent means reciprocal, and 1/2 power means square root. So square root of 16 is 4, reciprocal power, 1/4. Now, in the next set of problems, it says write in log form. Well, to start, let's put log. The base of the exponential function becomes the base of the log. Now remember, the exponent goes on the other side of the equals, and then that 36 is going to go right here. You should be able to do the circle of life and get what you started with, and that's exactly what we see here. Same thing for part B. With part B, we're going to start with a log, put the base of the log as the base of the exponential form, and then over the equals, we should have the 3/2, and then we can put the 27 here. So notice 9 to the 3/2 power equals 27, and that is a true statement. Finally, log, the base is 4, go over the equals, that's the exponent, and that should equal 1/2. So note that that is exactly what the original problem stated. Now, for your quiz, you will have a non-calculator portion where you will be asked to evaluate expressions without using a calculator. For all of these problems, we'll use the circle of life. Starting with part A, 2 to what power equals 2? Sometimes I'll do a little box like 2 to what power equals 2 and think about how I'd fill in that box. I've seen some students even use an x and say 2 to the x power equals 2, and then they're trying to solve for x. Well, in the case of this problem, it would just be 1. 2 to the 1st power equals 2, and that is the answer to this problem. Same thing with part B. 5 to what power equals 1? Well, we know anything to the 0 power equals 1. Part C is a little tricky because it's 9 to some power equaling 3. Well, I know 9 to the 0 power equals 1. That's too small. But 9 to the first power equals 9. That's too large. So I'm looking for an exponent between 0 and 1, which means a fractional exponent. Well, remember that anything to the 1/2 power is the square root. Anything to the 1/3 power is the cube root. And anything to the 1/4 power is the square root twice. So with that being said, what do I want to do to 9 to get 3? Well, I want to raise it to the 1/2 power. So note that the square root of 9 is equal to 3. This problem sometimes tricks people, but it's really very simple. 5 to what power? 5, because that doesn't even look like a 5. B to what power is b to the x? Well, just think about it. B to what power is b to the x? It's got to be x. B to the x power equals b to the x. With part E, rewrite that square root of 5 as 5 to the 1/2 power. And here's another one that's super simple. 5 to what power is 5 to the 1/2 power? Well, it's got to be 1/2. For part F, 3 to what power is 1/9? Here's another one that's a little tricky, but let's think about this. 3 to the 0 power is 1. Well, that's not going to work. Note that if you do 3 to the 0 power 1, that's too big already, which means we need negative exponents. Remember, negative exponents mean reciprocals. So I really want to think about 3 to what power is 9 and then take the reciprocal of that by using a negative exponent. Well, 3 squared is 9, so we're going to use a -2. Now, going to this next part, this one's very interesting because if you focus on what's just in the exponent, we would say 5 to what power is 25, and this answer would be 2, which means the whole exponent equals 2. But then if I said what is 5 to the 2nd power, it would equal 25, which is our final answer. You're going to see that this is actually a property that if you ever have an exponential function being raised to a log function that has the same base, these in a sense cancel out because they're inverses of each other. And what we get is whatever number's right here. And you'll see down below that's actually a property. It's right here. Final couple in this set, I'll keep the color green. If you ever have a natural log and there's no base, you should remember from last year that that base is e. So e to what power is e to the 8th? It's got to be 8. And then finally, e to what power is 1? Anything to the 0 power equals 1.